Today we're going to be looking at streams and rivers, which is surface water in our freshwater unit. So first of all, a stream is basically a small river. Both are formed by water running off the land into rills, gullies, streams, and rivers. So the area of land that feeds water into a river is called a drainage basin or watershed. So in this diagram, you see two different drainage basins. The boundary between the two is called a divide. So on the left side of this divide, all of the water drains into this river, and on the right side of the divide, all of the water drains into this river. The largest river basin in the U.S. is the Mississippi, which covers the entire Midwest. The divide on the East Coast is the Appalachian Mountains, so everything to the east goes into the Atlantic Ocean. Everything into the west flows into the Mississippi and eventually the Gulf of Mexico. To the west of the Mississippi River, the divide runs through the Rocky Mountains, and everything to the west of that flows into the Pacific Ocean. So everything in this watershed, all of these smaller rivers like the Missouri, are tributaries that feed into the Mississippi River, which ultimately, at its mouth, empties into the Gulf of Mexico in New Orleans, which sits on top of the Mississippi River Delta. We can divide rivers into three zones. We start with the source zone, which is the headwaters, the transition zone as it's moving into lower altitude on flatter land, and ultimately the floodplain zone, which is very shallow and wide as we get close to sea level. So starting with the source zone, these are usually in your higher altitudes formed by snowmelt that runs off into smaller streams that eventually feed into rivers. They're very narrow, clear, cold water that's fast moving, so we see a lot of waterfalls and rapids. Because of this, there are high amounts of dissolved oxygen that comes from the air. So we don't need a lot of plants for photosynthesis, which is a pretty good thing since because of the rapids, you're not going to have very many rooted plants. The fish that live here are adapted to cold water, like trout. Others have flat bodies that can wedge themselves under stones in the moving water. In a transition zone, they're a little bit wider and deeper because there's a more gentle slope, so we don't have the waterfalls and rapids that we do in the source zone. A larger volume of warmer water is carried because this is further down the drainage basin, so you have tributaries that run into larger rivers. It's warmer because it's slower moving and able to absorb sunlight. There's more producers like phytoplankton, so we don't depend on oxygen from the air. There is a lower level of dissolved oxygen, so the type of fish live there are adapted to that, like the black bass you see below. In a floodplain zone, this is where you are closer to sea level, so the streams are very wide. They're going to start off deep, but as they get in the lower elevations, they're going to become very shallow. They tend to meander, which means they curve over broad, flat valleys. As they slow down, sediments that are carried are deposited, and we get these very shallow, muddy rivers where sometimes you'll see sandbars in the middle. Because they're shallow and slow-moving, we start to see rooted plants. We also depend on algae and cyanobacteria for oxygen. There is still low dissolved oxygen because it's very slow-moving and muddy, so the type of fish that live there, like carp or catfish, can survive in the muddy, low dissolved oxygen levels. The area surrounding these rivers, once we get close to the mouth, are called floodplains. They're very flat, and when the river floods, that areas are completely covered with water. So this is a before and after picture. When the river floods its banks, any of the sediments that are carried get deposited on the floodplain, which makes for a very nutrient-rich soil, and we use these areas for agriculture, as you can see in these pictures on the right. On the left, this is a satellite view of the Mississippi River. You can see the meanders or the curves. The area surrounding is a floodplain, which in the second picture, you can see it's covered with during a flood. Here's another example of a meander in a river. When a river meanders, because it's so slow moving, a lot of times the curves can actually get cut off and form what we call Oxbow Lakes because they look like the footprint of an ox. And so as the river moves, it continues to curve or meander. So look right here. In this area, eventually what will happen is the river is going to cut through this area, and this will get cut off and become another Oxbow Lake. And here's another closer look. And you can see the sandbars and how wide and shallow this area is. So looking at our 3 stages, in our swarth zone, it's very fast moving. We have a narrow V-shaped valley running through higher elevation. As it starts to slow down in that transition zone, it becomes wider, it's deeper, it's got more water. And then we have our floodplain zone where it's close to sea level. We have all of that nutrient-rich soil that's used for agriculture. However, that area is going to be covered with water when the river floods. There are things that we can do to help prevent the flooding. One is building levees, which are basically usually ridges of sediment on either side of the river so that when it floods, the water can still rise without going over the levee. Sometimes we use sandbags, as you can see in this picture here, but most of the time they're going to be just ridges of sediment. Here's an extreme example of a levee that was built when they knew the floodwaters were going to be coming. And that is it for streams and rivers.